Well, right now, as you read this, your brain is using about 20 watts of power. That is roughly the same as a dim light bulb. And with that 20 watts, you are doing something that we do not fully understand. You are thinking. You are having thoughts. And the question I want to talk about today is this: what actually is a thought? Not in some philosophical sense. Not what does it mean or where does it come from in some mystical way. No, no, no. I mean physically. What is happening in your head right now as you think about this question? What is a thought made of? You see, your brain weighs about 3 pounds. That is roughly 2% of your body weight. But it uses 20% of your energy. Think about that. 1/50th of your mass consuming 1/5 of your fuel. And what is it doing with all that energy? It is thinking. It is you right now understanding these words. It is you remembering what you had for breakfast. It is you planning what you will do later. All of that is happening in 3 pounds of tissue in your skull. And here's the thing. We can describe what happens physically. We can measure it. We can watch it happen. A thought is not some mysterious substance floating around. It is a pattern of electrical activity moving through networks of cells. Specific, measurable, physical processes. But then you get to the really strange part, the part that nobody can fully explain. How do these physical patterns become the experience of thinking? How does electricity in neurons become the feeling of having an idea? Let me tell you what we do know, and then we can talk about what we do not know. Your brain contains approximately 86 billion neurons. Now, that is a very large number. If you tried to count them, one per second, it would take you about 2,700 years. You would need to start before the pyramids were built and count continuously until now. That is how many neurons you have. And each one of those neurons is connected to other neurons. A single neuron can form up to 10,000 connections. We call these connections synapses. So you have 86 billion neurons, each one potentially connected to 10,000 others. The total number of synapses in your brain is approximately 100 trillion. 100 trillion connection points where signals can pass from one neuron to another. Now, here is what happens when you have a thought. Patterns of electrical activity spread across networks of these neurons. Thousands of neurons, sometimes millions, all firing in coordinated sequences. And these patterns encode information. The pattern is the thought. But let me back up. Let me tell you how a single neuron works, because this is where it starts. A neuron is a cell. It has a body like other cells, but it also has these long branches reaching out from it. Some branches receive signals. We call those dendrites. And one long branch sends signals out. We call that the axon. The axon can be very short, or it can be very long. Some axons in your body stretch from your spine all the way down to your toes. That is one single cell with a projection 3 feet long. Now, the neuron sits there with a voltage across its membrane. The inside of the cell is negatively charged compared to the outside, about negative 70 millivolts. That is the resting state. The neuron is ready like a loaded spring. When signals come in through the dendrites, when other neurons tell this neuron to fire, something remarkable happens. Channels in the cell membrane open. Sodium ions rush into the cell. The voltage flips. In about 1 millisecond, the inside of the cell goes from negative 70 millivolts to positive 40 millivolts. That is a swing of 110 millivolts. This voltage spike travels down the axon like a wave. We call it an action potential. It moves fast. Depending on the type of axon, it can move anywhere from 1 meter per second to 100 meters per second. The fastest signals in your body travel faster than a car on a highway. And when that spike reaches the end of the axon, when it reaches the synapse, something else happens. The electrical signal triggers the release of chemicals. Little packets of molecules called neurotransmitters spill out into the tiny gap between neurons. They float across. They land on receptors on the next neuron. And if enough of them land, if the signal is strong enough, that next neuron fires too. That is the basic mechanism. That is how information moves through your brain. Electrical spikes triggering chemical releases, triggering more electrical spikes. One neuron talking to the next, which talks to the next, which talks to thousands more. And a thought is a pattern in this activity. Now, you might be thinking, well, that sounds simple enough. Neurons fire, signals move, patterns form. But here is where it gets complicated. Here is where it gets interesting. A single thought involves millions of neurons firing in a coordinated pattern. And these neurons are not all in one place. They are distributed across your brain. When you think about, say, a coffee cup, neurons in your visual cortex are active, representing what it looks like. Neurons in other areas represent what it feels like to hold, what the word cup sounds like, memories of drinking coffee, the abstract concept of containment. All of these patterns distributed across different regions, all active at the same time, all coordinated, and the coordination happens because neurons that fire together strengthen their connections. There was a neuroscientist, Donald Hebb, who figured this out. In 1949, he proposed that when one neuron repeatedly triggers another neuron, the connection between them gets stronger. The synapse becomes more efficient. People summarize this as neurons that fire together wire together. So your thoughts are not just patterns of activity, they are patterns that have been shaped by experience. Every time you have had a thought about a coffee cup, you have strengthened the network that represents coffee cups. The pattern becomes easier to activate. It becomes a memory, a concept, a piece of knowledge. But here's the thing. This all costs energy. Remember, your brain uses 20% of your body's energy. Where does that energy go? What is it doing? Well, every time a neuron fires, it uses energy. The action potential, that voltage spike, requires moving ions against their concentration gradients. After the sodium rushes in and the neuron fires, the cell has to pump those ions back out. It has to reset the voltage. That takes energy. Specifically, it takes a molecule called ATP, which is the energy currency of cells. Each action potential uses about 10 to the negative 10 joules of energy. Now, that is a very small number. One action potential is nearly free. But your neurons can fire up to 200 times per second. And you have billions of neurons. And at any given moment, millions of them are active. When you add it all up, thinking costs about 20 watts of continuous power. Your brain is a 20-watt computer made of meat, running on glucose and oxygen, generating patterns of electricity that somehow become your thoughts, your memories, your sense of self. And you know what? We can watch this happen now. We have technologies that let us see brain activity while people think. Functional MRI can show which regions of the brain are using more oxygen, which means they are more active. EEG can measure the electrical rhythms on the surface of the scalp. We can see that different thoughts create different patterns. If you think about moving your hand, neurons in your motor cortex light up. If you imagine a face, neurons in your fusiform face area activate. If you solve a math problem, your prefrontal cortex shows increased activity, different thoughts, different patterns, always. But here is the question that nobody can answer. And this is where the physics stops and something else begins. Why does any of this feel like something? You see, I can tell you exactly what happens physically when you have a thought. Neurons fire at specific frequencies. Neurotransmitters cross synapses. Patterns of activity spread across networks. Energy is consumed, heat is released, the chemistry is well understood. That is all physics and chemistry and biology. Standard material science. But none of that explains why there is something it is like to be you. Why is there subjective experience? Why does the pattern of electrical activity in your brain, when it represents a coffee cup, come with the feeling of thinking about a coffee cup? Why is there an inner experience at all? This is what philosophers call the hard problem of consciousness. And it is called the hard problem because nobody knows how to solve it. Think about this. We can build computers. We can make machines that process information, that have internal states, that react to inputs and generate outputs, and nobody thinks those computers are conscious. Nobody thinks there is something it is like to be a calculator. The calculator processes numbers, but it does not experience processing numbers. So what is the difference? Your brain is processing information too. It is neurons firing, patterns forming, signals moving. That is information processing. Why does your information processing come with consciousness, with experience, with the feeling of being someone? I do not know. Nobody knows. You can say, well, maybe it is the complexity. Maybe when information processing gets complex enough, consciousness emerges. And that is possible. But we do not know what the threshold is. We do not know what kind of complexity matters. The brain is complex, yes, but so is the weather. So is the economy. Are those conscious? Or you can say maybe it is the specific physical substrate. Maybe there is something special about biological neurons that silicon transistors do not have. Maybe consciousness requires this particular chemistry, this particular arrangement. And again, maybe. But we do not know what that special thing would be. We do not know what physical property generates experience. Some people think consciousness is fundamental, that it is a basic feature of the universe, like mass or charge, that every physical system has some tiny degree of experience, and complex systems like brains have rich integrated experience. This is called panpsychism, and it is interesting. But it does not really explain anything, it just moves the mystery to a different place. Other people think consciousness is an illusion, that there is no hard problem, that we are just confused about what we are asking, that once you fully explain the information processing, once you account for all the neurons firing and all the patterns forming, there is nothing left to explain. The feeling of consciousness is just what information processing feels like from the inside. But I find that unsatisfying, because the feeling is the thing we are trying to explain. Saying the feeling is just what the physics feels like does not tell me why the physics feels like anything at all. This is not a failure of science. Science has done brilliantly at explaining what thoughts are made of. We know the molecules, the cells, the electrical signals, the energy costs. We can map the patterns. We can predict which neurons will fire when you think specific thoughts. We can even decode some simple thoughts from brain activity. If we watch your motor cortex, we can tell which direction you're about to move your hand before you move it. But none of that touches the question of experience, why you feel like someone, why there is a you at all. Now, here is what I think is important. The fact that we do not understand consciousness does not mean thoughts are not physical. They are. Thoughts are patterns of neuronal activity. That is established. That is not controversial. If I disrupt the neurons, I disrupt the thoughts. If I stimulate specific neurons, I can make you have specific experiences. If I damage part of your brain, you lose specific abilities. The mapping is tight. Mind and brain are connected in every way we can measure. So thoughts are physical. The patterns exist in the physical world. They follow physical laws. They consume physical energy. They can be measured with physical instruments. But somehow, these physical patterns also have an interior. They are something. And that something, that subjective quality, is not captured by the physics. It is like asking, what is the color red? I can tell you about wavelengths. I can tell you that red light has a wavelength of about 650 nanometers. I can explain how photons hit your retina, how cone cells respond, how signals travel up your optic nerve to your visual cortex. I can describe the entire physical mechanism. But none of that explains what red looks like, what it is like to see red, the experience of redness. And if you had never seen red, if you were born blind, I could not explain it to you. I could give you all the physics, all the neuroscience, every fact about wavelengths and neurons, and you still would not know what red looks like. Because the experience is not in the facts, it is something else. That is what we are dealing with when we talk about thoughts. The physics is one thing, the experience is another, and we do not know how to connect them. Now, does this mean there is something non-physical going on? Some soul or spirit or mysterious force? No, not necessarily. It might just mean we do not understand the physics completely yet. There might be aspects of physical reality that we have not discovered. Properties of matter or organization or information that give rise to experience in ways we cannot yet describe. Or it might mean that consciousness is not a problem to be solved, that it is a basic fact, like existence itself. You cannot explain why there is something rather than nothing. Some questions do not have answers. They are just features of reality. Maybe consciousness is like that. Maybe asking why experience exists is like asking why the universe exists. There is no answer, it just does. But here's what we can say. Right now, as you process these words, millions of neurons in your brain are firing in coordinated patterns. Electrical signals are racing along axons at tens of meters per second. Neurotransmitters are flooding across synapses at rates of hundreds of molecules per millisecond. Energy is being consumed, about 10 billion ATP molecules per second in your brain. Heat is being released. Chemistry is happening. And somehow, in the midst of all that physical activity, there is you. There is the experience of understanding, of following an argument, of wondering about consciousness. The electricity and chemistry are creating thoughts, and those thoughts feel like something. That is what a thought is. It is both things. It is a physical pattern, measurable and material. And it is an experience, subjective and felt. We understand the first part. The physics of neurons, the chemistry of synapses, the energy costs, the signal speeds. We can describe that with precision. The second part, the experience, remains mysterious. And maybe it always will. But I think that is okay. I think it is wonderful, actually. Here we are, 3-pound lumps of biological tissue consuming 20 watts of power, generating electrical patterns that somehow become thoughts, feelings, ideas, selves. We are the universe trying to understand itself. Atoms arranged in such a way that they can think about atoms. And we do not fully understand how that works. We can describe the mechanism, we can measure the activity, but the experience, the feeling of being someone, of having thoughts, of existing as a conscious observer, that remains beyond our full grasp. Think about that. You are a pattern of neuronal firing that knows it is a pattern of neuronal firing. You are matter that has become aware of itself. That is strange. That is beautiful. And that is what a thought is. It is 86 billion neurons firing in coordinated rhythms. It is 100 trillion synapses passing signals. It is 10 billion ATP molecules consumed per second. It is 20 watts of continuous power. And it is you, right now, understanding this, feeling something, experiencing existence. We know what it is made of. We do not know why it feels like anything. And that gap between the physics and the experience might be the most interesting question we have ever asked. That is science. We find answers. And sometimes the answers lead to deeper questions, questions we do not know how to answer yet. Maybe we will figure it out. Maybe consciousness will turn out to be something we can fully explain with physics and chemistry and mathematics. Or maybe not. Maybe this is one of those questions that sits at the boundary of what we can know. Either way, the fact that we can ask the question, the fact that patterns of electricity in your brain can wonder about themselves, that is remarkable. That is worth thinking about. And that thinking, that wondering, that is what thoughts are for.